DC motor, whether series motor, shunt motor, you have a rotating part called armature. This is the armature coil, correct? Single turn armature coil. This shows that this is called as a commutator. You can see the two gray color, this one. They are metallic, generally made of copper or bronze something. And this one. Then you have two brushes touching this brush 1, brush 2. And through this only we are supplying the voltage to armature. For example, I say VA plus minus. So current goes through the brush, from brush is touching, because this is a commutator brush, because the commutator armature is rotating, correct? How will you supply voltage? Otherwise, why? If you just solder the wire directly on the commutator, the armature wire, then wire will get entangled. One or two, that's not possible. That's why this arrangement, correct? Commutator brush supplies the voltage from the battery to the actual armature coil. We are showing a single turn coil. So that means the current from this one goes and come back. So that means this is plus, this is minus, because the current is flowing like this. Current direction, if you see that, that's how it is shown here. So that means I have my battery like this, plus minus VA. So this is the current IA is going. IA from this brush is touching the commutator. Commutator is attached with the armature coil. Okay, so the commutator rotates along with this one. So in that case, now if you supply current like this, you can see that there are two arms, correct? The same wire only. So this is top side of the coil, this is bottom side of the coil. So our right side, I can say the right side of the coil, left side of the coil, but it's single turn coil. So the current enter from here. So there are two forces created. One force you can see shown as K, other one as M. So one force is moving up. This part, this coil is moved up. This coil is pulled down. That means there are two, this one, field magnets. So for example, north and south. So this is pulling up. This is pulling down. So now because of that, you can say that's what is shown here. Correct? So now that as it start rotating, now it was a horizontal. Then now the coil is moved by 90 degree. Correct? From the original position, starting position is shown in A. You can see that the position of the commutator is changed. You can now it is center. The brush remains constant. Brush is fixed and the commutator is rotating. So commutator mode. Now it is rotated by 90 degree. Now you see that the forces acting top coil like this. The bottom coil is down, still working. Now, next step, because the armature is going to rotate 360 degree. So, okay. So, it is not full. I think here, yeah. Then, same thing is shown here. Okay. Now we can see here the there's a break, correct? So break means this part of top coil is connected here, correct, to this. And see here, this is like this. Here also it is like this. But here, when you come here, you can see that this part, top part of the coil is getting connected with the plus and minus. You can change. This is still touching. After that, once it comes here, you can see that it will become a reverse. Correct? The commutator element, see that the voltage from the battery is connected to the armature coil properly, because there are two halves, and through which the commutator current is the forces generated by the top and bottom coil. But net so one coil is pulled up, same coil, top up, bottom up. But you can see that here it is here, but automatically after one turn it comes here, correct? One rotation. After making complete 360 degree rotation, it comes to this. That's how the magnetic force created by field magnet and the armature magnet is going to react with each other, pulling or pushing together, and they create the rotational force we call as a torque. Torque production is done here. Already we saw the equations. Torque production equation, already we know that. Okay. So we saw that, and I talked about the speed versus current. correct? The graphs, we saw that. Then we start a series motor, correct? The series motor in which in the series motor, you know that the field coil and the armature coil are connected in series. This is the field coil. This is the armature coil. Both are connected in series with the supply voltage. So that's why we call series motor. Already I talked about the current flowing from the battery through field coil to armature coil. Again comes back. We call ISC. ISC is the series coil, field coil current, which is same as armature coil because they are connected in series. So the KVL, according to KVL, the voltage supplied Vs should be equal to voltage drop across coils. Voltage drop across coil. So this is the voltage drop across current into voltage equal to, we say the VSC. Voltage is current multiplied by resistance. Similarly, the same current is flowing. Actually, I can write this also IA because same current entering IA into RA is called as VA, voltage drop across the armature coil. VB is called back EMF generated by in the armature coil as the speed of the armature coil changes and the armature coil going to cut the flux generated by field coil. So this is the KVL equation, already we talked about it. So net thing is torque producing series motor TM is proportional to IA into phi SC or field coil. This is nothing but field coil, correct? The magnetic field coil multiplied by current flowing through the armature coil multiplied by some constant. The proportion, they call proportional motor constant. We can write TM equal to KM into IA into phi SC. Phi, so in some book, they just put phi. That means automatically understood that it is the field coil, the phi F or phi SC. These are the terminal used. So we know that we can write like this. Now, we know that in the TM,